I'm Jacob. I'm Matthew. And today we're doing the egg drop project.
Alright, so the purpose of our egg drop project is to demonstrate our understanding of stoichiometry in the periodic table, then applying that to protecting an egg. Our final airbag design contained a freezer-sized Ziploc gallon bag which held 12 ton tablets, and that's about the equivalent of 6 grams of calcium carbonate, and then 150 milliliters of crown muriatic acid, which is hydrochloric acid. The airbag is constructed by measuring 150 milliliters into the plastic bag, then straining the air out of the bag and resealing it. Then you twist the bag until it's tight above the surface of the liquid. Then you want to crush 12 ton tablets up and insert it into the bag. Untie the bag, then shake vigorously to begin the reaction. You may have to poke holes in the bag, because this reaction actually produces a lot of air. So it depends on how strong your muriatic acid is. The balanced chemical equation is as follows. 1 molecule of calcium carbonate and 2 molecules of hydrochloric acid yields 1 molecule of each calcium chloride, carbon dioxide, and water. When first beginning our project, we tried determining the limiting reactant if 28 grams of calcium carbonate was combined with 12 grams of hydrochloric acid. Although we eventually used 12 times the amount of hydrochloric acid and only half the calcium carbonate, the limiting reactant is still the same in our final project. Now, when creating our project, our airbag, originally we were using 28 grams of calcium carbonate and 12 grams of hydrochloric acid. This is much different with the now 6 grams of calcium carbonate and 150 milliliters of hydrochloric acid, which we're using now. Either way, the calcium carbonate is the reactant in excess, while the hydrochloric acid is the limiting reactant. So the amount of calcium carbonate we had left over is 11.5. So this kind of indicates that no matter how much we play around with the amount we use, calcium carbonate is always going to be the reactant in excess. So here's our balance equation previously stated, and we use this to find how many moles was in each reactant. Then after that, we determine the mass of the calcium chloride by multiplying the moles of each of the reactant times the mole ratio with the calcium chloride in the numerator, and then we multiply the result by the molar mass of the calcium chloride. So after that, we determine that hydrochloric acid yields less calcium chloride than calcium carbonate and is the limiting reactant. So this makes calcium carbonate the excess reactant. Then we determine the mass of calcium carbonate that reacted with the limiting hydrochloric acid, and then we use that to determine the calcium carbonate left over, which was the pre-mentioned 11.5 grams. So this kind of indicated to us that calcium carbonate would always be left over and always be in excess. Alright, so in our first trial, we used 28 grams of calcium carbonate and 12 grams of hydrochloric acid, and although that amount is way off from our final design, we did learn how the Tums, the calcium carbonate, affected the muriatic acid. And so later on, we used a larger bag, a gallon bag, and I believe between trials 2 and 3 we made that change. And then we also added more hydrochloric acid while lessening the amount of Tums we had, because we ended up wasting a lot during that first trial.
Day 2, and we decided to switch our chemicals up. So originally we were using drain cleaner and aluminum, but now we switched on to carbonic acid, which is Tums, and then hydrochloric acid. And so we finalized our design for the airbag, tried some tests out, and we got about this much air, and I think this should be sufficient enough for our egg not to pop.
Good job.
Alright, so for our next trial, we used about 12 tablets of Tums, which is about 6 grams of calcium carbonate, and then we also switched up to using 80 milliliters of muriatic acid, and this created a lot of air. However, a lot of it did not stay put as the bag popped, so we needed some way to relieve that pressure, which we found out in a later trial.
Yeah.
Alright, so for our third trial, we used 150 milliliters of muriatic acid and 12 tablets of Tums, which is about 6 grams of calcium carbonate. So this is the final amount we need, but we needed to tweak the design before we were ready for our final egg drop project. So going into our final egg drop project, we actually punched 8 holes into the bag, and we thought this would release some of the pressure and alleviate some of the problems we had previously. But it actually ended up hurting us, and our egg cracked as a result because we let too much air out.
Project, we have 12 Tum tablets and 150 milliliters of hydrochloric acid.
Yeah. So it was the day of the final project, and we only had a quart-sized bag with us. So despite doing all our calculations with a gallon-sized bag, we did improvise, adapt, and overcome. So we used muriatic acid, and we used 80 milliliters while using 8 tablets of calcium carbonate or Tums. So we learned that the reaction actually did produce a lot of air. However, it was too much air, as our egg bounced off and cracked.
The egg drop project got about 80 milliliters of hydrochloric acid and about 8 tablets of Tums. Alright, go baby. Drop it.
Obviously, our egg drop did not go as we planned. We had we'd used a quart-sized bag the day of, and despite tweaking how much of the reactants we used, we did not successfully protect our egg. And so if I could do it again, I would be more prepared, and I'd bring a gallon bag, and I'd also do the stoichiometry and find all the limiting reactants from the get-go, because that would make our whole project much more easier.